simplifying expressions, we're talking about terms and like terms. Okay? Now, terms are the parts of the equation, or parts of the expression that are being added together. Okay? So the parts of the expression that are being added together. Okay? Like terms are terms that have the identical variable including the exponent. Okay? So, for example, on number 2 that I told you to write down, number 2 says 3a plus 9 minus a. Okay? These highlighted yellow parts are the terms. Okay? The ones that we have blue underneath are the like terms. So the like terms are the blue ones. The yellow ones are the terms. So in number 3 you have we have 18 plus 4b plus 6. So the terms are 18, 4b, and 6. The like terms are 18 and 6. We call these two terms constants. Okay, anytime you have a number by itself, not with a variable, it's called a constant. Okay, so what would be the constants in number 2? In number 2, 3a plus 9 minus a, what would be the constant? The 9. The 9 here is the constant. In other words, does the value of 9 ever change? Is 9 some days 7, some days 12? No, it's always 9. Okay? So a constant is a number term that does not have a variable. The next item we need to have is coefficient. Okay? Coefficient is the number in a term next to next to the variable. Okay, so in this expression, number 4, in number 4, you have negative 8c plus 4 minus 5. So, the constant are the ones highlighted in yellow. The coefficient is the one highlighted in blue. Okay? And the terms, that's a term, that's a term, and that's a term. Okay, so in this problem, the coefficient is negative 8. The terms, negative 8c, comma, 4, comma, and this will be a little confusing to you, but I'll explain it to you, negative 5. Those are the terms. I'll explain the negative 5 to you in a minute. The like terms is 4 and negative 5. The constant is 4 and negative 5. Now, where we're coming up with the negative 5 is here. In the problem, negative 8c plus 4 minus 5. You must change all subtraction to addition, just like in Chapter 6. Okay, so that means I must do this. Negative 8c plus 4, change that to addition, do the opposite of the number behind it, which makes it negative 5. So this negative 5 here is where I came up with the negative 5 over there. Gracie? You and Copeland got something going there? Why are you over there, Copeland? Oh. So, not only do you not have your book, but now you need to sharpen your pencil. Okay, why don't we get those guys you were talking to between class to do this for you? Use a pen or something. We're not getting up and doing stuff like that. Now, so I want to look at another problem. I want to look at this problem right here. This is problem number 6. 3x plus 4 minus x. And they want to identify the coefficients Didn't put my I in there. They want us to identify the coefficients, the constant terms, and like terms. Okay, so that's what they want us to identify. 1, 2, and 3 in this problem. So the first thing I need to do is take 3x plus 4, change that to addition, do the opposite of positive x, which is negative x. Now, when there is no number in front of the variable, there is always a 1. Okay? Because how many x's do I have there? 1x. All right? So, they want us to first identify the coefficients. The coefficients are the numbers that are in front of our variables. So what is in front of the first x? So our coefficients is the number in front of our variable. What is the number in front of the first x? What? 3. What is the number in front of the last x? Negative 1. That's your coefficients. Your constant terms remember, our constant terms are the numbers that are by themselves without variables. So what is the constant term in this problem? 4. And the last one they want us to see is the like terms. The like terms are those terms that are exactly identical as far as the variable goes. Not what's in front of the variable, but just the variable. Okay? So our constant terms here, we have an x, or our like terms, we have an x there and an x there. So our like terms are 3x and negative 1x. Those are your like terms. So, this is the answer to number 6. All right, so I want you to try number 7 on your own. Okay, number 7. Okay. Let's look at this, see if you've come up with the same answers. First thing, I have to change that to addition, do the opposite of that, which is negative 4y, plus 5y, change that to addition, and do the opposite of that, which is -8. So, what are the coefficients, Gracie, in this problem? Yes, -4 and 5 are the coefficients. They are the numbers that are in front of the variables. Okay. Copeland, what are the constant terms? 10 and what? 10 and -8. Okay, those are your constant terms. Now, this one's a little bit more difficult. What are the like terms? Okay. -4y and 5y. What else? And yes. Okay. Now, you have two pair of like terms. Okay, we have the -4y and 5y, and then we have the -8 and 10. Okay, the reason that -8 and 10 are like terms is because they're both constants. Also, do either one of them have a variable? No. So their variables are identical, they just don't have one. Okay, and so that's why you can do that on those. All right? So I want you to try number 8 on your own. Okay, try number 8 on your own. All right, who's got something for me? Haley Perez. I want to know the coefficients. Okay, not the z. Remember, the coefficients are the numbers in front of the variables. 7 and 9. You're half right. Juliana. Yeah, 7 and negative 9 is the coefficients. Okay, so 7 and negative 9. Remember, we have to change the subtraction sign in front of 9z to addition, and then do the opposite of positive 9, which is negative 9. Okay, now, what is the constant terms in that problem? Gracie? Is it what? No, not constant. It's 7 by itself. Okay, so it's just 2. So the constant is just 2. Okay, so what is the like terms in the problem? Anthony, give it a shot. Correct, and there's one more. Yeah, z. So your like terms are 7z. I'm going to erase that because that looks like a negative. Negative 9z and z. And we call that 1z because there's a 1 in front of it. You don't have to put the 1, but you just need to know that it's there. Okay? Now, that brings us to the next step. Let's go back to our original problem, number 2. Okay? Number 2, the directions say simplify the expression. Okay, so we have the expression 3a plus 9 minus a. Okay, first thing we did is that we changed the subtraction to addition. Okay, now we're going to talk about how we simplify. Simplify means to put in lowest terms. Okay, so simplify means to put in lowest terms. What we're going to do is, we said a while ago, what were the like terms in this problem? We did it right at the first of the notes, I think. Did we ever get to the like terms? Yeah, but in this problem, did we give them? No, we didn't. Okay. Now that we know what like terms are, what are the like terms in problem number 2? $3a and negative a. Okay? So what I'm going to do is I'm going to rearrange this problem and have the like terms right next to each other. Okay, now, we said that there is a 1 in front of the a. See, this is where I've talked to you, several weeks, even before Christmas, I talked to you about knowing your negative and positive rules. See, here's a negative and positive rule, and not only that, but we've thrown a variable in there to try to confuse it even more. Okay? So, for this one, what I'm doing is I'm taking 3 plus negative 1. What is 3 plus negative 1? 2. Because we subtract the absolute values. Remember? We subtract 3 minus 1, which is 2. The larger absolute value is positive, so we bring it down. We also now bring the a down. So that's 2a plus 9. Now, I've told you that this day is eventually coming, okay, when you're not going to be able to simplify problems down to just one number. Okay? 2a plus 9 means this. This is the answer. That's it. The reason being is because of this. When I asked you a while ago what the like terms were, you said we had 3a and negative a. Well, those are the only two things you can put together. 9 is not the same. The reason that 2a plus 9, the reason that 9 is not the same is because it doesn't have an a with it. Okay? It would be like I said this. Let's say I had this. Let's say that I had 2 apples plus 9 oranges. Can I put that together and say I have 11 oranges? Can I put it together and say I have 11 apples? No. Okay? So we can't say that we have 11 apples or 11 oranges because we don't. Can't do that. That is why they are not the same. 2a is not the same. Now, let me show you another example. If I had this problem right here, if I had 2 times 4 plus 9, what would you do first? We would multiply 2 times 4. Okay? Then we would add the 9 to it. Well, this is the same thing as the a. We don't know that it's 4. It could be any number. It could be, negative 2, 20 million, whatever. But if down here we have to do this step first before we can add the 9, then we have to do the same thing up here. But I can't because I don't know what a is. So therefore, I'm done. 2a plus 9 is your answer. Okay? Now, let's try number 3. I want you to try number 3 on your own. Number 3 was 18 plus 4b plus 6. Okay? I want you to simplify the expression. Okay, I want you to simplify the expression. Do that now. All right, who has an answer? Copeland? Huh? Nope. Okay. Haley? Nope. Okay, now, I just said, obviously we weren't paying attention. Does this term and that term look similar in the sense of I have a number in front of a variable? So I just said, and you just agreed with, that I couldn't do anything else with that until I multiplied it together. So now you just totally thrown that out the window and said, oh, I can do anything I want to with it. I'm just going to combine it all. I've got 18 oranges, 4 bananas, and 6 apples, and I'm going to say I got 4 bananas. No, you're not. You don't. So how can you do it now? You can't. Okay? What are the like terms in this problem? Somebody raise your hand and tell me what the like terms are in that problem. Haley. What? What? Okay. What up there does 4b have in common? So we're looking at this term, and this term. For something to be alike, it either has to have the same variable in it, including the same exponent, or no variable at all. So, is there any other B's in the other two terms? No. So that term is not like any other term. Okay? So, this is a constant. This is a constant. Can we put two constants together? Are they the same? Are constants the same? Yes, they are. They're numbers. Numbers can be added together. So therefore, I have 18 plus 6 plus 4b. So I have 18 plus 6 that I can put together. That makes 24. Plus 4b. So it's like I have 24 marks over here. Okay, you'll say that's 24. And then over here, I have 4 B's. So is there any way that you can put those two things together? No, they're totally different. So your answer then is 24 plus 4b. Okay? Now, here's what I want you to do on the work tonight. We're not going to cover the simplifying part first yet. What I want you to do is I want you to do 2 through 4 and 6 through 11. And for each of those problems, I want you to do the coefficient, the constant terms, and the like terms for each of those problems. I want you to list it out just like I've done there and just like we did in the notes. Then we'll continue on with the simplifying part tomorrow so we have more time to explain it to you. Okay, so that's your homework.